Assalamualaikum student. Bismillahirrahmanirrahim. So today we will discuss the questions that you have done before PKP. So question 4.14. A mass of 1.5 kg of air at 120 kPa and 24 degrees Celsius is contained in a gas-tight frictionless piston cylinder device. The air is now compressed to a final pressure of 600 kPa. During the process, heat is transferred from the air such that temperature remain constant. So calculate the work input during this process. So for temperature remain constant, this is the keyword here. So this is isothermal case. So you have to use this formula. W equals to mRT ln P1 over P2. Many students got confused whether to use P2 over P1 or P1 over P2. Later we will see the calculation and whether this works or not. So M 1.5 kg R your gas constant, you have to use 0.287 kilojoule per kg Kelvin. So you have to convert this temperature to Kelvin. So you have to add 273. So you will get 297 Kelvin. Okay. 297 Kelvin. Ln P1 initial pressure is 120 kPa over 600 kPa final pressure. So this one cancel out, K cancel out with K, kg. So you left with kilojoule. You will get negative 206 kilojoule. So here, negative. If you put P2 over P1, 600 over 120, you will get a positive number. Positive number, it does not make sense because this question is compressed. You must have a negative number for the initial calculation. But don't get confused because the question asks you to calculate the work input. Okay, work input. This negative 206 kilojoule is the work done on the system. So your work input is positive 206 kilojoule. Okay, so this is the final answer. Okay, next question. 4.15. During some actual expansion and compression process, since in piston cylinder device, the gas have been observed to satisfy the relationship PVN equal to C, where N and C are constant. Calculate the work done when a gas expands from 350 kPa and 0.03 meter cube to a final volume of 0.2 meter cube for the case of N equals to 1.5. So here this is polytropic case. You have to use this formula. W equals to P2 P1 divided by 1 minus N. So from the question you have V2, you have P1, V1, you have N. Missing information is P2. So you have to calculate P2 using this relationship P1, V1, N equals to P2, V2, N. So P2 equals to P1, V1 divided by V2 over N. So equals to, the P1 is 350 kPa multiply by V1, where V1 is 0.03 meter cube over 0.2 meter cube. Power of n, your n is 1.5. So plug in all the values in calculator, solve this, you will get 20.33 kPa. P2 is this number. So now you have all the value to calculate for work done. So W equals to P2 20.33, V2 0.2 minus your P1 350 0.003 divided by 1 minus 1.5. So your final answer is W equals to 12.9 kilojoule. So the question asks for work done. So you have to convert this to work input. So this is correct. Next question. 4.17. A frictionless piston cylinder device contains 5 kg of nitrogen at 100 kPa and 250 Kelvin. Nitrogen is now compressed slowly according to the relation PV power of 1.4 equal to constant until it reaches a final temperature of 450 K. Calculate the work input. See, work input, not work done. Okay, so this n, your n is equal to 1.4. So you have to use this formula because the question gives you temperature, initial temperature and initial final temperature. Unlike previous question give you initial and final pressure. So here you have to use this formula for polytropic. MR T2 minus T1 over 1 minus N. Okay, so your M, mass. So you actually have everything. T2, T1, your mass, and your R. Okay, so mass is 5 kg. R 0.2968 kilojoule per kg. Okay. T2 450K minus 250K. Divide everything by 1 minus 1.4. So W is negative 242 kilojoule. So remember, this is the work done on the system. Negative. Compress. Okay, this is work done. The question asks for work input. So your work input is a positive number of this. So 742 kilojoule. So this is the final answer. Alright, so let's have a short break.